In front of me here, you'll see we've got 3 different thermometers. Yes, they are thermometers. And what we're going to do is calibrate Fahrenheit, Celsius, and Kelvin. Since we're talking about temperature scales, these are the most common ones. These are the ones we're going to see the most often. So we have to know how they relate to one another. We'll do the lowest temperature possible, absolute 0. So at each of these, what's great, if we make this Fahrenheit, make this Celsius, make this Kelvin. What's great about Kelvin, 0 is 0. Very cool. For Celsius, hold on, let me put that outside. 0K. You guys hear about the scientist that fell into his absolute 0 experiment? He was okay. For Celsius, it's negative 273.15 degrees Celsius. And for Fahrenheit, it's negative 459 degrees Fahrenheit. The next one we want to do is the point at which water freezes. For Fahrenheit, hopefully we know this is 32. This is where we start looking at snow days, even though RIP snow days, now that everything can be done online. For Celsius, it's right at 0. And for Kelvin, we're going to have 273.15 Kelvin. Notice, I'm not saying degrees Kelvin, just Kelvin. You may hear me slip up and say it once or twice during a lesson, but remember, degrees mean it's arbitrary. So for this one, they chose what temperature does seawater freeze at. That's 0 degrees Fahrenheit. For this one, they chose 0 degrees and 100 degrees to try and figure out their scale. Again, arbitrary points. This one is based on an absolute value. At 0 Kelvin, you have 0 energy. If I go to double the energy in Kelvin, I should have double the temperature. And finally, we have up here at the top the boiling point of water, and we have 373.15 Kelvin. This is going to be 100 degrees Celsius, and this is going to be 212 degrees Fahrenheit. You guys should notice that the difference between here and here is 100, the difference between here and here is 100. That's intentional, and what it means is that a change in 5 degrees Celsius is the same as a change in 5 Kelvin. It makes these units very useful. It means anytime you do like a initial temperature minus final temperature, you can use Celsius or Kelvin, but they both work out. But let's look at how these units compare using our formulas now. Let's see right here. A degree Celsius. Degree Celsius is going to be equal to 5/9 of a degree Fahrenheit plus 32. The reason for that is when we want to get 0 degrees Celsius, we would have to have negative 32 for that to cancel out. So basically it ends up where, well, you'll see when we flip it around. Degrees Fahrenheit is going to be equal to 9/5 times degrees Celsius plus 32. The parentheses are important. So when we're at 0 degrees Celsius, we should end up with just 32 degrees Fahrenheit. Pretty neat. And then finally, to go from Kelvin to Celsius, you literally just add 273.15. Now, for our purposes, the 0.15 is not going to be super relevant. So if you just want to put, I think it's actually like 0.149 something. But if you just want to do 273, I'm happy with that. So these will be our units for converting. And one last thing, like I was talking about earlier, Kelvin is an absolute scale. So no degree sign. The reason for that is at absolute 0, there's no energy left, no motion of any particles, at least in the kinetic realm. So we have an absolute point, no need to call it a degree scale.